All of us at Toyota believe in a future that will be safer, greener, and easier for everyone. This could be the beginning of the end for electric vehicles. Whispers from deep inside the automotive world suggest that Toyota is about to unleash something extraordinary. An engine powered not by gasoline, electricity, or hydrogen tanks, but by water. Yes, water. Long dismissed as a dream or a backyard experiment, the water-powered engine may finally become a practical reality. And Toyota might just be the one to make it happen. If true, this isn't just a breakthrough, it's a disruption, the kind that rewrites everything we thought we knew about clean energy and transportation. So, is this really happening? Let's find out. For decades, the idea of a water-powered engine has lived on the margins, floating between myth, science fiction, and late-night garage experiments. It sounded too simple, too impossible. While independent inventors and curious engineers tried to make it work, the mainstream auto industry stayed silent. The technology was often dismissed as impractical, inefficient, or simply a hoax. But now things are changing. And fast. Toyota, a company known for reshaping automotive norms, seems to be stepping into this space with purpose. This is the same brand that pioneered the hybrid movement with the Prius and pushed hydrogen fuel technology with the Mirai. Now, reports suggest Toyota is developing a fully functional water-powered engine, one that doesn't require battery packs, fossil fuels, or high-pressure hydrogen tanks. The system works through real-time electrolysis, separating hydrogen from water inside the vehicle itself. That hydrogen is then burned in the engine like natural gas. It's not a concept anymore. It's a working machine in the making. What once sounded like wishful thinking might soon be rolling off production lines. With Toyota behind the wheel, the line between science fiction and reality just got a lot blurrier. At its core, Toyota's water-powered engine operates on a beautifully simple principle: electrolysis. Water, as we know, is made of hydrogen and oxygen. By running an electrical current through it, the engine separates these elements on demand. Unlike traditional hydrogen cars that rely on bulky high-pressure tanks to store hydrogen gas, this engine generates what it needs in real time, right inside the vehicle. Here's where the innovation gets even more intriguing. The separated hydrogen is immediately directed into a combustion chamber, where it ignites and powers the engine much like compressed natural gas would. The oxygen is vented safely or used as part of the combustion process. There's no external hydrogen infrastructure needed, no constant supply chain risk, and no rare earth metals involved. All of this happens from a simple tank of distilled water, equipped with electrodes powered by a compact electrical system. It's not an electric car, it's not a hydrogen fuel cell, it's a new category entirely: mechanical, chemical, and elegant. This closed-loop process is efficient, clean, and easy to scale. Toyota isn't just improving existing tech, they're rewriting the playbook. Electric vehicles have long been hailed as the future. But behind their quiet motors lies a trail of environmental trade-offs: lithium mining, rare earth metal extraction, and battery disposal issues that quietly erode their green image. Add to that the global challenges of building massive charging infrastructure and dealing with long recharge times, and the EV dream starts to show cracks. Toyota's water-powered engine offers an elegant counterpoint. It sidesteps the environmental cost of battery production entirely. No cobalt, no nickel, no lithium. Just water. An abundant, easily accessible resource. Refueling is as simple as pouring distilled water into a tank. No waiting for hours at a charging station. No dependency on the power grid. More impressively, this engine produces nearly zero emissions, putting it on par with electric vehicles in terms of cleanliness, but with far greater convenience. There's no need for high-voltage power sources or special refueling stations. In theory, anyone with access to clean water could keep their car running. In a world searching for practical sustainability, Toyota's engine isn't just cleaner, it's simpler, cheaper, and more adaptable. It doesn't replace electric vehicles, means, it challenges their dominance from the ground up. In regions where electric vehicle infrastructure is scarce and fuel prices are volatile, Toyota's water-powered engine could be nothing short of revolutionary. Many developing countries face daily struggles with access to charging stations, high import taxes on lithium batteries and unreliable electricity grids. For them, electric vehicles aren't just expensive, they're impractical. But water is available almost everywhere. A vehicle that runs on distilled water removes the need for complex logistics. Someone said that on no industrial, no high-voltage stations, no oil refineries, no specialized fuel imports. Just a plastic container, a few liters of water, and a bit of smart engineering. That simplicity is powerful. It means mobility without dependency, energy without geopolitical entanglements. For countries with limited oil reserves or unstable economies, this could mark the beginning of true fuel independence. It could also open up low-cost transportation to communities previously locked out of the automotive market. And let's not forget maintenance. These engines, due to their mechanical simplicity, could be far cheaper to repair and maintain than electric vehicles or traditional combustion engines. For the millions still priced out of clean mobility, Toyota's water engine might be the key that finally opens the door. Now first, like always, be sure to hit the like button down below. It helps us out tremendously with the reach of this video. One of the biggest misconceptions about water-powered engines is that they're weak or experimental, but emerging prototypes suggest otherwise. In fact, Toyota's design could rival or even outperform traditional gasoline engines. That's because hydrogen, once separated from water, is an incredibly energy-dense fuel. Some estimates suggest it can deliver up to 3 times the energy per unit compared to gasoline. Early conversions, like the one done by Iranian scientist Aladin Qasemi, already show promising results. His modified Peugeot 405 reportedly achieved 30 to 40 miles per gallon of water, better than its original fuel economy. If this can be scaled with Toyota's precision, we're looking at a new standard for fuel efficiency. Safety is another major advantage. Unlike gasoline or stored hydrogen, water is non-flammable and non-toxic. There's no risk of explosion from the fuel tank. Because the hydrogen is produced on demand, there's little chance of gas buildup or uncontrolled combustion. The absence of large battery packs also reduces the risk of electrical fires, a concern with some EVs. With fewer moving parts, simpler mechanics, and minimal heat generation, Toyota's water-powered engine isn't just efficient, it's safer, smarter, and engineered for real-world reliability. As groundbreaking as Toyota's water-powered engine sounds, the road to mass adoption won't be without obstacles. The first is skepticism. For years, water-fueled vehicles have been tied to fringe science and unproven claims. Changing that perception will take time and proof. Even with Toyota's reputation, public trust in a new fuel technology must be earned through performance, safety, and transparency. Then there's the technical challenge of scaling the system. Real-time electrolysis requires stable electrical input and highly efficient electrodes. Ensuring this process works reliably in all climates, terrains, and vehicle types will take extensive field testing. The durability of components under long-term use remains a key question. Regulatory hurdles may also slow progress. Global automotive standards are built around gasoline, diesel, electric, and compressed hydrogen. Lastly, there's cost. While water is cheap, the engine's core components, particularly those enabling safe and efficient electrolysis, may initially be expensive to produce, but Toyota's advantage lies in its scale. Still, if history has taught us anything, it's this: Toyota